So let me get you started on some of these. So number one, pH of the solution, 50 milliliters with 0.1 molar solution of acetic acid and 15 milliliters of sodium acetate. Is number one a titration problem?
No.
No.
Buffer problem.
It's just a buffer problem. Okay? There you go. When you get to number two, you got 20 grams of acetic acid, 20 grams of sodium acetate to make a 2-liter solution. Determine the pH of the buffered solution. What are you going to have to do with the 20 grams of acetic acid? Change that into
Moles.
what do you do with 20 grams of sodium acetate? Moles. You have, when you're doing that molar mass, some kids make this mistake. When you got that 20 grams of sodium acetate, you have to include the sodium because that's what it's bound to. Just don't use the acetate. That's what we're going to worry about, the acetate ions, but when you're doing that conversion. Now, Christmas, you listen to me. How many significant digits are in 20.0?
3.
When you do the conversion into moles, you need to keep at least 3 significant digits, okay? Do not round it.
Oh, I should be doing that on pH, because
Round a thing.
Okay. Now,
That's an 18.
on B, on 2, it says, write the net ionic equation for the reaction that occurs when sodium hydroxide is added to the solution. Is this a buffered solution on number 2?
No.
I didn't
I
look.
get determine the pH of the buffer.
I didn't read a buffered solution.
Let's read. Bird, I'm not gonna lie, I wasn't even looking at the paper at all.
Then why didn't you answer?
Because the way you phrased the question made it sound like the answer should have been no.
I'm not gonna lie.
That is true.
I thought the same thing. but
Is number 2 a buffered solution? The answer is, oh, if you say it like that, yeah, it's gonna be no. I don't care if it says a buffered solution.
See, I didn't read and I just chose to stay quiet.
So what do you have in the
No one else said
beaker?
anything. I was just being brave.
Acid.
50-50
The
shot.
acid and the
Anion.
anion. What's the hydroxide going to react with?
Anion.
The anion, no.
acid.
It's going to react with the Okay, so when you do number 2, refresher on how I want this done. Here's your sheet of paper. Here's going to be number 2. Here's going to be a line. Do not have a whole bunch of answers here and then this work gets strung out down half the page. You keep these answers right beside that work. I am not going to find an answer here and then try and sort through a whole bunch of random chicken scratch over here that doesn't match up with this. Okay? You keep these answers right beside the work that they generate. Okay? Now, when you get to 5, you've got nitric acid and potassium hydroxide. What do you know about nitric acid?
Strong.
Strong acid, right? So that is not a buffered solution. When you get to number 6, you have hypochlorous acid and 0.1 molar potassium hydroxide. Is hypochlorous acid a strong acid or a weak acid? Keep that in mind. When you get to number 6, when you get to number 7, you got hypochlorous acid, by the way, and then you're going to add the sodium OCl to it. Right away, how is number 6 different from number 7? It's a buffered solution. Okay? When you get to number 10, look at those cations and anions. If the cation could give up a proton like the NH4 did, pH is going to go down. If the anion is off of a weak acid, the pH is going to go up because it's going to start a secondary reaction. I beg of you, these are difficult to grade if you run everything together. When in doubt, space it out. Okay? Right? Leave me spaces so I don't have to run through all of these problems and try and figure out when one stops and the other one starts. I beg of you, leave spaces. Okay, Kevin, we're done. That was a tough lecture.